Hello everyone and welcome to another problem solving session with Special Maths Academy. So in this video, we'll be solving the first geometry problem from the just concluded National Olympiads, Nigerian National Olympiads. So let's go straight to the problem. Okay, so the problem says points A, B, C, D, E, and F are on a circle such that AB is parallel to CD and BE is parallel to CF. So first of all, let's try to explore this. Okay. So let's say we have AB parallel to CD and BE, so let's say this is BE, parallel to CF. So let me just swap this so that okay. So now looking at this question, let me just put my notation for parallel lines. Okay. So looking at this question, well, let's just complete the hexagon and see what we can get. Okay. So first of all, what do we know about cyclic hexagon? Well, not so known. But then if a hexagon is cyclic, so let me just say this is a random hexagon. So I'll use a set of different letters from what's already in the question. So let's say G, H, I, J, K, L is cyclic. So what are the things we can note? So we can divide it into two cyclic quadrilaterals. So this angle here, G, and let's call this let's split I, the angle at I, into two. So let's say A and B, and then this angle here, K. What can we see? We can see that G plus A, so angle G plus A is equal to 180 degrees. And we can see that angle K plus B equals 180 degrees. It's just sum of opposite angles in a cyclic quadrilateral. So when you add these two equations together, we have angle G plus angle K, and we have A plus B is the angle at I, so angle I equals to 360. So we have that if a hexagon is cyclic, then the opposite angles, the alternating angles, are sum of alternating angles, that's this angle plus this angle plus this angle is 360. And we can do the same thing for the other ones. Okay, so that's just it. So we just take note of that and see how we can apply that. So I'll just write here, if G, H, I, J, K, L is cyclic, then this. Okay. So now looking at the, so let me just, so looking at this two triangles. Now, since this line here is parallel to this line, and this line here is parallel to this line, it implies that their intersection, the angle at their intersection will be equal. So that's this angle here is equal to this angle. So if you just have two parallel lines in space, so if you have this line is parallel to this line, and this line here is parallel to this line, their angle, this angle here, if you say this angle here is theta, and this angle here is also going to be theta. And proving this is quite easy. So you can just draw. So you can just try to form a parallelogram. So you can extend this so until these two lengths are equal, and then you draw a line here, and then you extend these lines so that they're equal, and then you draw again so that you have a parallelogram. Okay. And then you can extend this here. So you can say this angle here is equal to this angle, corresponding angles, and this angle here is equal to this angle. So it's just one of those things here. So it's there are many ways of proving this. So take note of that. Then another important things about circles is that if two chords subtend the same angle, then the two chords are equal. And that's because of the extended law of sines that relates the chord in a circle to the angle it subtends. Now look at the chord FD. FD and AE, these two chords are equal. So it means they subtend the same angles. Okay? So it means the two chords are equal. Well, how can we apply that? We see that there's no equality for AE and FD in the options, so we can kind of like skip that for now. So let's go on. Let's just try and have fun with the problem, although it's something that some of you will know how to do in the example, yeah, and it's quite understandable. Okay, so if we join this to this, okay, right? So we see that if you say this angle here is theta and this angle here is theta, okay, so we get this angle here is 180 minus theta. Why? No, cyclic collateral. AB, EF is a cyclic collateral, so we get this angle here is 180 minus theta. And in a similar vein, we get that this angle here is 180 minus theta. So what do we have? This angle here is equal to this angle. So we have another pair of parallel lines. Quite interesting. So we have AF is parallel to DE. And voila, we have it in the options. And I believe if I was in the exam hall at this point, I'd be very happy because I can quickly go on to the next problem. And that's a good place to end. So see you in the next video, guys.